Well, howdy students. This is going to be a video that explains how the four quantum numbers come together to fill atomic orbitals, where they're at on the periodic table, and their atomic orbital diagrams. So you've got four quantum numbers at the top. You've got N, that's the first quantum number, L, which would be the second, M sub L, which we do not cover in Chem 1, and M sub S, which we also do not cover in Chem 1. So those last two columns, you don't have to quite focus on here in this course, but let's focus on the first two and see where they end up on the periodic table. So here we go. If N is 1, we're looking at the principal quantum number, N, which is the energy level. Excuse me. L is 0, which is a spherical shape. And we have our first two other quantum numbers there, which we're not going to look at. The energy level says that we have one S, which gives us one atomic orbital to fill. So my first electron goes in there, and that would be right there at hydrogen. Okay, so that's the element hydrogen there. Then we have a spherical shape. So this box down here is going to list the shape for us. Shape, this is orbital diagram. And this is just the periodic table and where everything is there. And these are quantum numbers over here. Quantum numbers. Okay, let's keep going. So the second one is also in 1s. Each atomic orbital can actually hold 2 electrons. And so that would be helium over here. And you'll notice that it is a filled shell. And when it's filled, that equals satisfied. And we're going to learn about that in a little bit, but that's when we start getting noble gases. Okay, we move down to the second row. L is still 0. We're in the spherical shape. There's our two quantum numbers. The first electron would go into 2s, and that would be for lithium. Okay, and then you'll notice that here the shape gets larger. We have a larger spherical orbital. The second one fills in, and we go down to beryllium there. And we don't have a filled energy level, so this is not a noble gas. Beryllium is not a noble gas, although it does fill the 2s shell. But if we keep reading left to right on the periodic table, we end up getting to L equals 1, which is the peanut-shaped orbital. And we have our first two other quantum numbers there. Now, we have 3 atomic orbitals in the orbital diagram because there's 6 elements there with 6 potential electrons. So the first one goes in, that would be boron. And according to Hund's rule, I have to give everyone a piece of candy before I go back and give someone a second piece. I have to give every orbital an electron. The shape of the orbital is peanut shaped now because we are in the P block of the periodic table. Okay, so we'll keep moving on. Our next one would be carbon, and it will be a second peanut shaped orbital. And then I have my third electron that goes into the third orbital, which would be for nitrogen. And I have a third peanut orbital. So I've got an X, a Y, and a Z formation, 3-dimensional space. So then Hund's rule says I can go back and give everyone else a piece of candy. That would be oxygen, fluorine, and then neon. Okay. Then we go down to a larger energy level. That would be N equals 3. And we're back in the S block, which is L equals 0. So we have 3s. That would be for sodium. And what you'll see on the shape down here in the bottom right is that the 3s is even larger. I can fill in a second one, which would be magnesium, element 12. I follow along the periodic table. I reach the P block. First element there would be aluminum. And you'll notice that the peanut shape is even larger now because it's in a higher energy level. That was aluminum. And then here we've got another one, which would be silicone. and then phosphorus. And then that'll give us our third peanut shape there. And then we can go back, fill in for sulfur, chlorine, and argon. We've got 3 more electrons. So that's sulfur, chlorine, and argon. And we can keep going. 4s will be down on the 4th row with potassium. That would be letter K. And the second one there would be calcium. And you'll notice that our shape got even larger. This is the 4s out here. Now, let's notice something. When we get here, and this is where we'll stop today after we do this, when we get here to this row and hit the D block in the center, this is huge, right here. It drops from 4s down to an energy level of 3d. And because there's 10 elements there, we'll have 5 atomic orbitals, 5 circles in our diagram. So 3d would be 3d10, and I would have a potential 2 electrons, 2 electrons, 2 electrons, 2 electrons there. And because it's 3d, whatever shape orbital we have in here would only go out to the 3rd level in energy. It wouldn't go out to the 4th because it's only 3. So this is a depiction of what the quantum numbers are doing and how we classify electrons.